Hello again. We continue our exploration of derivatives of different types of functions. This time we're going to be looking at logarithmic functions. Now, we don't know yet how to find the derivative or why it looks as it is. We're going to combine past experience, knowing the derivative of any exponential base function, along with the ideas found in implicit differentiation. We're going to connect those two to find the derivative of log base b of x, so log any base. Ultimately, what we want to do, so we're going to be taking the derivative of d dx of y equals log base b of x. And what we're going to do is I'm going to rewrite this using exponential form. In exponential form, this is b to the y equals x. I'm going to apply my derivative, so taking d dx of b to the y equals x, applying my derivative to that, well, we've got the natural log of b multiplied by b to the y. That is using our derivative rule. Now remember in chain rule that we've got y is an equation in terms of x. We're going to be multiplying by dy dx equals, well, derivative of x is 1. We want to solve for dy dx, so I'm going to divide by everything. We've got dy dx, that's e, is equal to 1 divided by the natural log of b multiplied by b to the y. Now we're going to make a substitution. We've got that b is equal to log base b of x, so that will be, we're going to substitute in for that. We have this is equal to 1 over ln b multiplied by b to the log base b of x. Well, exponent base e and log base b are inverses, so those cancel. We have 1 over the natural log of our original base multiplied by x. So putting that together, the derivative of log base b of x is 1 over natural log of that base multiplied by x. Notice that x is outside of the natural log, just as it was when we were taking the derivative of our exponential statement. That's a new rule to remember. Let's apply this to base e and see what that means. So we're going to have the derivative of natural log, that is the derivative d dx of log base e of x. So we have 1 over natural log of e multiplied by x. Well, natural log and exponent base e are inverses. Ln natural log of e, that is just 1. So we're left with d dx of the natural log of x is 1 over x. Isn't that nice? Now, it's worth noting that the domain for the natural log is greater than 0. So our domain for our derivative is 1 over, for our derivative 1 over x is x greater than 0. And think about why that makes sense. If we think about the graph of y equals natural log of x, we have this vertical asymptote, x equals 0, and our function looks like that. Our derivative, d dx, being 1 over x, 1 over x has a vertical asymptote at x equals 0. It starts off at the left as we're approaching 0 from the left at positive infinity, and it's decreasing with a horizontal asymptote at 1. So it makes sense that, okay, very, very steep positive, because our function was very steep positive, less positive as we go further and further out to the right. And so our derivative makes sense in terms of slope. The derivative of natural log of x is 1 over x, with the domain being x greater than 0. Let's put this into action. Let's practice. Differentiate the natural log of x cubed plus 1. So what I see is chain rule, because we have that x cubed plus 1 inside our natural log. F prime of x, then, the derivative of natural log is 1 over the argument inside, x cubed plus 1, chain rule, multiplied by the derivative of the inside is going to be 3x squared. So our derivative is going to be 3x squared over x cubed plus 1. Now, notice the chain rule. When we have the natural log of some function, it's the derivative of the argument inside divided by the inside. Derivative of natural log of sine of x. So dy dx, we're going to have 1 over derivative of sine of x multiplied by the derivative of sine of x, which is cosine of x. So we have dy dx is equal to cosine x over sine x, which is cotangent of x. Next up, find the derivative of the square root of natural log of x. Now, remember that this can be rewritten. S of x is natural log of x raised to the 1/2 power. So we need to apply the chain rule. First up, we've got the derivative of the outside, the derivative of the square root function. So we have 1 over 2 square root, the argument ln x, multiplied by the derivative of the inside. Derivative of natural log of x is 1 over x. So we have f prime of x is 1 over 2x multiplied by the square root of natural log of x. Let's keep going. Differentiate. F of x equals log now of 2 plus sine x. Notice that there is no base written there. When we do not have a base, we're assuming that to be base 10. That's known as common log in the United States. So f prime of x, we're going to have 1 over, we're going to apply that rule, ln of the base, so natural log of base, multiplied by the argument to the inside, 2 plus sine x, multiplied by chain rule, derivative of the inside is just cosine x. So we have our derivative cos x over natural log 10 multiplied by 2 plus sine x. Let's keep on going with a few more examples. Here, I've got x plus 1 divided by the square root of x minus 2 inside the log. So this is a quotient rule inside of the natural log. Our derivative, first off, we have 1 divided by the argument. So I'm going to write that as 1 over x plus 1 divided by x minus 2. Now we're going to apply the quotient rule with the chain rule. So multiply by the derivative of the inside. So quotient rule, we call derivative of the top. Okay, derivative of x plus 1 is 1 multiplied by the bottom. So we've got square root x minus 2. Subtract the top, x plus 1 multiplied by the derivative of the bottom. Derivative of the square root of x minus 2 is 1 over 2 root x minus 2. Chain rule, for x we multiply by 1. So it's going to be 1 over 2 square root x minus 2 all over the denominator squared. So all over x minus 2. Neating this up, dy dx, the first statement, we have 1 over x plus 1 over the radical x plus 2. That's the reciprocal. So this turns into square root of x minus 2 over x plus 1. We're multiplying by square root of x minus 2 minus, let's neat that up, that is minus x plus 1 over 2 root x minus 2 all over x minus 2. If I get a common denominator with that, I multiply this by root x minus 2 over root x minus 2. Actually, that's going to be 2 root x minus 2. We've got dy dx equals root x minus 2 over x plus 1 multiplied by, we have 2x minus 2, subtract x plus 1 all over 2 root x minus 2 multiplied by 1 over x minus 2. That is, fine with that. Since this is multiplication, we've got root x minus 2, root x minus 2. Here we've got 2x subtract 4, subtract x, subtract 1. And one last step, we have dy dx is equal to x subtract 5 divided by x plus 1 multiplied by 2 multiplied by x subtract 2. You can, of course, leave it without simplifying it, but there is a simplified statement. That's all we got. Enjoy.